Okay. This is our first problem today out of 3 that I want to go through today. Goal today, number 1, talk about how to find possible rational roots one more time. That's what your homework is based on today. You have 6 problems in your homework, 6, that's it. And it's to find rational roots. Once you find them, then you have to find the rest of the roots. These are basically x-intercepts. The problems I picked today are cubic functions like this, where you have to find potential ones. Now, this process I'm showing you right now works for any size. The reason I picked cubic functions for your homework is because after you find one, you can do quadratic formula, or you can do other means to find the other ones. So I try to pick kind of easy ones. I will not guarantee that every single problem today will have a set perfect number for the roots, like there might be imaginaries. We talked about that yesterday. They may have actual numbers, they might have some decimals, they might have some radicals. So we'll kind of look at that today. But this is our first example. This will get us kind of in the flow of things. Then what we're going to do is we're going to change it up, because the majority of this problem is based on division, if you don't know. It's like after you find one, you divide it out. So what we talked about in class was, like, especially last Friday and Monday this week, was we talked about how to synthetic divide things. Like divide that problem out, and what you're left with is called a reduced function. And whatever was left, you can factor that thing apart. You can take a quadratic formula on it, figure out the remaining. Because on this problem, how many potential x-intercepts are there? 3, or n-intercepts, I guess. There's 3, right? Now, does it have to be 3? No, but we can find them. So the problem is, I picked this problem on purpose because this is one I saw in the book. When you look at this problem, we have to pick out possible rational roots. What's the big red flag on this problem? What's the main part that makes this thing difficult? What do you think? How do you find rational roots? What did we do the last couple days? What numbers do we use to find x-intercepts? Last and first. Yep. So I take the 128, you put it over the 1, and you break these up. And what the red flag should be is that 128 is huge. That's scary. That's a scary number, because that has a lot of possible factors. Question?
So for the homework, do you want us to use the rational root?
Yes, I want this possible way, because if you can't factor it, let's say like this problem, I think you can, but let's say you can't factor it, I want you to use rational roots to get practice with it, because on the test there's 1, so this is like your time to actually use it. So yeah, so if you didn't hear, I do want you using this function, this style problem, and no, I'm not giving you numbers like 128. This is to over-prepare you to know how to do it. But 128, we know it's what goes into this is 1 and a 128. Bless you. We know that 2 goes into it. It's 2 and what, 64? Yeah. Let's see. 3 doesn't go into it. How do I know 3 doesn't? When you add these up, it doesn't give you a number that's multiple of 3. 4 definitely goes into it. 4 and 28. 32. 4 and 32. Let's see. 5 doesn't go into it. 6 doesn't, because 3 doesn't. 7, no. 8, yeah, 8 goes into it. It's 8 and 16. Is that correct?
Okay, go.
16, yeah. And I think that would be pretty much about it. Okay. Is there any others? Is 12 going to it? No, 12 can't. It's 3. All right. We'll stop there. I think this is enough where we have kind of a set. Okay, then there's a 1 on the bottom because 1 doesn't break up. And what you do is make every combination of the top number over the bottom number, or numbers if there's plural. So if there's weird bottom numbers right here, you have to make every combination of this first number over whatever numbers are down there, second number over all these combinations. So you can have a lot. You don't need to put repeating numbers. So if you know, like it was 128 over 2, that's 64, you don't need to write that one again. So just be careful of that. But what I would do if I was doing this problem, because I know like it's positive, negative, any of these numbers. These are the numbers I would check first. Should go in order here. 4, 8. Why would I check these first? Easier ones. Check them first. Like maybe one of them works. And what I mean by works is what I would do is take each of these numbers one at a time and plug it in. Like actually take like the positive 1, plug it into this thing and see if it gives you 0. If it gives you 0, that's an x-intercept. That's what it means. Or if that number didn't work, try -1. Maybe that -1 plugging into all these n's would give you 0. That's what I'm looking for. We're looking for x-intercepts that would give you 0 for the y number. Because these are the x numbers potentially. The answer that comes out of that thing would be the y number. Okay? I'll speed up the chase here. So if we're plugging in a bunch of numbers, the number that I know that works for sure is a -4. So I'll just jump to the chase. Boom. We found -4 works. Now, to show that, because I want to speed up the process here a minute, -4 cubed minus 8, -4 squared minus 16 times -4 plus 128. Okay, -4 cubed is -64. -4 squared is 16 times 8, which is a negative, actually it's -128, exactly 16 times 8. This is a positive 64, and that's a positive 128. So if, as you can tell, like those cancel, make 0, these cancel, make 0, boom, you got 0, right? So you know it worked. Like now again, most people just type in the calculator, fine, it works, fine. What we have to do now that we found one of them, like this is an x-intercept, right there. Now what is the, like what's the binomial that represents that thing? It's not just -4, but what do we write for the polynomial?
Max plus 4.
Yeah. You have to have those written down today. I want those explicitly. The reason why is when we find a number that works, you always use the number that would give you that, the polynomial that provides that root. So it's x plus 4, it's always the opposite number, by the way. Once you have this, this is basically what this thing would factor into if you could factor it. But anyway, so we found one. Now what I'm gonna do is, this is the part, like this is the new stuff today that I wanna cover. We're gonna divide it out. So we're gonna take the x plus 4 and divide this thing out of this polynomial, okay? So in your homework today, because you have 6 problems, you're gonna have to do this stuff where you find possible rational roots, you find one number that works, then you can divide it out. I recommend for your homework today, synthetic divide. It's faster, it's cleaner, it's the easier process for dividing. Because the numbers we're finding will be nice clean numbers like this. Okay, at least one of them will be. So let's synthetic divide this up. But did everyone understand how I plugged it in to find the ones that worked? Okay, again, I would just use the calculator to figure those out. You only have to find one. Once you find one, you don't need to keep going. You're just wasting time. You're spinning wheels. Because there might not be another one. Because again, it might only has potential. It has potential for 3, but maybe only one of them works. So now that we found one, since we found that the -4 works, we're going to divide it out. We're going to divide out the number that actually works. And then across the top here, you're putting the leading coefficients of that polynomial, and they have to be in order, descending order, biggest power to smallest. And if there's any missing letters, you have to put a 0 in for it. So I have all my letters, n to the 3rd, n to the 2nd, n to the 1st. So I have every letter accounted for, so I'm going to put the leading coefficients. 1, -8, -16, and a 128. And then draw a line. This is synthetic division. Seemed like last Friday when I introduced this, you guys were familiar with this, you're comfortable with it, you've done it in Algebra 2 a lot. Enough where you recognized it. Okay, so the rule is you drop the first number down of the original polynomial. You multiply by the number in the box. So I'm going to multiply by -4. So 1 times -4 is -4. You add straight down. You multiply by the number in the box. And notice that turned out to be positive now, because -4 times -12 is 48. You would add straight down. What is that? That's a 2, that's 32, positive 32. Then you multiply by the number in the box, it's -128, and you get 0. Then multiply, add, multiply, add, multiply, add. The big thing that always gets people when you start doing this for the first time, because you're gonna have to do your homework, is that they forgot the negative signs, like on the original problem, or they put the numbers out of order because they didn't notice it. And then the numbers don't work and they don't know why. Because the calculator told them that they were supposed to get 0, but they're not getting 0 at the end because you have them out of order, you forgot negative signs. That's kind of the red flag. That's why I want you to actually use your calculator first. Okay, but now, what we're left with is this thing. This is what they call the reduced function. These are the rest of the x-intercepts if you can factor it apart. If you can't factor it, you have to do quadratic formula to it. I think this one is factorable though, but anyways, it's gonna be x squared minus 12x plus 32. And again, how I knew that, it's always one less power than the original polynomial. Again, I know I just switched to x's. But it's one less power, so if it was, end of the third, now I'm at end of the second. And if you can factor this thing apart, that'll be the rest of the polynomial. So, is this thing factorable? Yeah, it is. So, that's the way I made it. Kind of works out nice and easy. So yeah, so it's negative, negative, x and x, or n and n, if you want to keep it to that. What are the numbers for 32? 4 and 8. Okay. So it looks like these are the rest of the polynomials. So it looks like my rest of my x-intercepts was positive 4 and positive 8. So it did actually have 3 x-intercepts. Now, you might find that you can't factor yours apart like that, like it didn't work out nice and pretty. So you'll have to do quadratic formula to that. Is everyone comfortable with the quadratic formula? Okay, good. And again, if it didn't work out nice and pretty, maybe it turned out to be weird radicals, do your quadratic formula and it'll figure out if there's any left. Because they might be imaginary, maybe it doesn't hit the x-axis 3 times. Okay, are we good with that? That's what your homework is. That's what I'm gonna give you. The reason why it's practicing dividing still, but it's finding roots, it's finding the rest of them, it's practicing like little things that you had to do in all those graphing problems we had this previous assignment of page 312 stuff. Okay? Okay, are we good so far? Okay, now, the new stuff we're gonna do today, this, I don't consider that new. The new stuff we're gonna do today still goes with this, okay? So, some people don't like synthetic, I don't know why. Some people don't like it, doesn't make sense to them, they don't understand the complex nature of it. So, what we're gonna look at today is long division. We're gonna look at long division. And so, I think this is kind of one of those things you just need to see it for the first time. And the reason why I brought this problem up first, to kind of review what your homework's based on, is because I'm going to use this problem for long division today, okay? There's a reason why I want you to know this thing right here. Because this problem, the original problem that I actually created was just doing this. Even though it had ends, it was, x plus 4, it was x minus 4, and x minus 8. These are the 3 parentheses I just typed into my calculator. It multiplied them together and it told me my polynomial. That was the thing I created on the board right there. Okay, what we're gonna do today is we're gonna long divide. I'm gonna pick one of these. We're gonna long divide it out, like practice long dividing, and what will happen is it should give me the other 2 that are remaining. So we'll do the 8 first. So what I'm gonna do is I'm gonna do this original polynomial, I'll change these to x's, because this will make more sense since I suddenly switched. All right, and what I'm gonna do is I'm gonna just pick one of these at random. I'm gonna pick this one, and I'm gonna show you if I long divide that thing out, like normal long division, not synthetic, but long divided out, it should give me the other 2 left over. It should give me the x plus 4, x minus 4. Does that make sense? It's like synthetic dividing, but it's doing a longer process for it. This is something that we need to practice, because the reason why I want to practice long division is that synthetic only works if you have very easy polynomials like this, super easy ones. The minute you have bigger polynomials that you need to check that are possible roots, like let's say it was a square term like a quadratic, you can't synthetic divide a quadratic out. You can only synthetic divide binomials out, like the x plus 4. So you can only check a single number at a time. But long division works on everything. It's guaranteed no matter what the polynomial is. It just gets messy sometimes. So we're gonna practice this. So what I should do is if I do long division, we're gonna practice just a very easy problem first. We're gonna divide this out, and what should be left over should be a representation of what this thing is, or some form of this, okay? All right, but before we get there, is everyone comfortable with the problem we just did though? I don't want to confuse anybody. This is like what you're doing in your homework. It should be fairly easy. And I picked very small numbers. I'm not picking numbers like 128. I'm picking numbers like 4 and 12. So so they're easy to figure out. Okay, good. All right, let's talk about long division here. Let's say I had a number like 321. Okay. Notice long division, you have a house. Okay, that's long division. There's a number on the inside. That number, this number in here is the actual dividend. This number on the outside, which I'm going to put out here, let's say I'm going to divide by 3. That number is the divisor. These are terms that you use when you talk about long division. So you have dividend, divisor. When you actually divide, all the things go down. It's basically a lot of multiplying and subtracting. That's what division is. It's kind of the opposite of multiplying. Multiplying is adding. But we're actually multiplying and subtracting a bunch of stuff here. The answer will be placed on the top. That's called the quotient. That's where that word actually comes from. A lot of people think, oh, quotient is divided. Yeah, it's the answer when you divide. And then sometimes there's remainders left over. There's things that, didn't divide in there perfectly, you'd have a remainder left over, which is kind of ugly looking. Now this problem should not have a remainder. I created it in such a way it shouldn't work, but it should work out perfectly because what is the inside number 3, 2, and 1? What does that add up to be if you add up the individual numbers? 6, 3 goes into 6. That's how I know it's going to long divide perfectly. Okay, so let's just practice this. I know this is stupid. This is like a 4th grade math problem, but this will show us the rules for how you long divide. Even if it's like a crazy polynomial, it still has the same rules, which is kind of funny. All right, so let's long divide this out. So what you do, I always work with this, and I try to make it the first number right here. So what do I multiply on the divisor to make it a 3? 1. You put it here. Now, if this number is smaller than the first, then you look at the second number with it. That's how it always works. So if this item is smaller than this item, then you have to look at the next 2. But 3 times 1 is the number 3. Again, you're multiplying basically. And then you subtract straight down. Always subtraction. Keep that in mind. You always subtract straight down. So you're going to get 0 here. Bring down the next number. So now we're checking the number 2. This is 0 and 2. Because what do you take times 3 to get 2? Well, that doesn't work, right? It doesn't work out perfectly because this number is too small compared to the 3. So you put a 0 here, it's a filler, and then you just bring down the next number. That's how it always works. You can always put a 0, bring down the next term, and then just keep going. How many times can 3 go into 21 now? 7. And so that'll be a 21, because 3 times 7 is 21. You always subtract straight down, and yes, you get 0. So it worked out perfectly. So that was a perfect, root of, or factor of 321. So the answer is actually 107. Did everyone understand like the 0 idea, like the filler, and you drop down the next number? That didn't work out. Okay, now I know this is stupid, 4th grade math problem. But the same problem is, it has all the complexities and all the basic form for how you divide polynomials out. So you multiply by the top number, you subtract straight down, you might have to carry numbers over and do like fillers, where you put in zeros, because maybe the thing doesn't work out nice and pretty. So let's do this long division problem. So it's gonna still work out to be the same problem as when you synthetic divide, because I'm picking very easy polynomials. But this can work for anything. Okay, and then I'll show you the concept. So I'm going to try to do 2 problems today so you can kind of see this. So this is my second problem today, and then I'll have 1 more, and then we'll be done for the day. All right, so first problem here. We're going to divide by an x minus 8. So this is the problem I'd like you to write down. So x to the 3rd minus 8x squared minus 16x plus 128. So this is the first problem I want to do today. Now we already know that this is a root of the original problem, but this is the first one we did today. We know it is a root, so it should work out where there's no remainder or anything like that. Tomorrow we'll look at problems where there is remainders, like what would you do with that thing. Again, hopefully you've seen this in Algebra 2, and I'm not the first one teaching this for the first time. But again, this is how you can find roots and check if there's more than one. Okay. All right. Anyway, this particular problem, what we do is you try to figure out what do you multiply in the first item to make it this. So what do I have to multiply in x to make it x to the third? X squared. You place it above the x squared term. That's where I lined it up. Some people don't understand that. You line it up above the correct letter when it matches. We are multiplying by the number 1 because these are both 1s here. I don't need to even put that. But again, that's where I line it up. Now when you do this, when I take x minus 8 and I take it times x squared, you have to write that thing right here. So x times x squared is x to the third. Negative 8 times x squared is negative 8x squared. Make sense so far? Okay, now, we're gonna subtract straight down. When you subtract, this is how you do it. You subtract, and you subtract this again. You subtract every item straight down. So really, the second item, if I subtract a negative, this actually becomes a plus. So what I always tell people is just you make the whole polynomial you just did, just make it opposite, because that's how you subtract it. Because you're going negative, 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 negative all the way across. Okay, when you go straight down, that makes 0, so that's gone. This also makes 0, fine, and you drop down the next item, right? 16x. Now, again, I'm on the same path. I want to try to figure out what I multiply on this thing that would make this 16x. Well, this has 2 items, right? It's a binomial. So drop down this next item here. So we're going to drop down this next item as well. The reason why I need to make this item the same size, like in length, as this one. So if this is 2 items like a binomial, this also has to be a binomial. So you have to drop down items. I'm not putting a 0 there because this x can actually go into 16x. I don't need to throw in a 0. I just had to drop down the number to make sure it's the same size. Again, you always have to drop down the next items. So that's how it always works. So what do we multiply on x to make it a negative 16x? Negative 16, okay. And that, where I'm putting it, is above the number in the back. Because again, I always line it up above the correct item. So if it has a letter on it, I line it up above the correct letter. If it's a number, I line it up above the constant in the back. So x times a negative 16 is negative 16x. Negative 16 times a negative 8 is a positive 128. And what do I do next? Okay, subtract straight down. So we're going to subtract, so I'm going to subtract negative, that's plus, subtract this number. So I'm always making them opposites. When I go straight down, this makes 0, this makes 0. So my remainders are zeros, it worked out perfectly. Now, what I said earlier, right, where you have filler numbers. There was technically a filler number. There was, I just didn't want to throw it in there. Okay, because, you know, the next number I dropped down was 16, right? And I was trying to get to it. I was trying to make this x is 16, negative 16. But did you notice I had to drop down the 128 to make it the same size? There was a filler there. The simple fact that I had to drop down another warranted me to put in a 0x in there. But I didn't want to put that in there. It confuses people when I do it. But anytime you put a 0, you drop down the next item. That's what I did over there. I put a 0, drop down the next number automatically. Well, that's what happened here. I just didn't want to put that. That really confused people. Like, then they try to multiply by 0. It's just waste time. But it is that same exact principle. That's why I picked that number, because it's the same concept. All right, but anyway, what you're left with, the actual quotient, this answer, that's the other 2 roots that we said. We knew that x minus 8 was a root of that thing. But what that thing represents, this is the reduced function. If you can factor this thing apart, this gives you the other x-intercepts. Or if you want to do quadratic formula, well, this is a difference of squares, right? It's x plus 4, x minus 4. That's exactly what I had here. You see that when you divide, you always get the other roots, no matter how you do it. Some people really do not like long division. It's just they hate it. They don't want it. They don't like it. They don't understand it. The concept is it's just doing long division from elementary days. Now, yeah, some people don't like that because they weren't very good at it, or they had a really bad instructor for long division for it. So they just didn't understand it's just multiplying and subtracting the whole time. But it's one of those things like once you get used to it, you can divide a polynomial by anything you want to see if it actually works. And that's what I want to talk about in the next problem. Okay, questions at all about this problem? Okay, I'm only doing one more and then we're done for today. It should take me about a minute or two. I'm not gonna do so much explaining, we're just gonna fire into it. Okay, last problem of the day. Hope I can get this done in 2 minutes. That's all I want to do. Alright. There should be. Okay, here we go. Last one. Last problem of the day. I'm just going to write it down right into the long division set, what you're kind of used to seeing. X cubed plus 2x squared minus 68x plus 120. And again, I know I picked a really big number there. You'll get used to it. X squared minus 8x plus 12. Okay. This is probably how you solve problems back in Algebra 2 days. You solve them in fractions, you try to factor them apart, you canceled out parentheses up and down type of idea. We're going into long division. I don't even want to waste time trying to factor that top thing apart. I'm not even going to do it. The bottom part, yeah, the bottom is kind of easily factorable. We're going to talk about that tomorrow. I'll come back to this problem tomorrow. But let's do long division. So what goes in the house? Top. Always top. So x cubed plus 2x squared minus 68 plus 120. On the outside, we have the x squared minus 8x plus 12. Now, not guaranteeing this is going to work out nice and pretty. Not going to. But I want to show you how we do this with a bigger polynomial. Because again, long division works for any size problem. Okay, what do I multiply on an x squared to make it x to the third? X, single x, right? I'm going to put that here, just a 1x. So it's all the way to the back, so I know my answer is really small. Okay, so I'm going to multiply this whole thing by x. So what I'm left with is x cubed minus 8x squared and then a 12x. That's multiplying this whole thing by an x and putting it down below. What do I have to do after I do that?
Subtract.
Always subtract, always. So we're going to subtract. So this is going to be negative, positive, negative. We're subtracting straight now. So if you subtract, that makes 0. This makes 10x squared, because you're adding now. And this makes a negative, what is that, 80x? And then I drop down the next number. Because again, that's the rules of long division. You always drop down the next item by instinct. Now, what do I have to multiply on this x squared to make it a 10x squared?
10.
10. So I'm going to multiply it by a positive 10. Because I want to make it exactly that number. So if it's negative, I have to multiply it by negative. But I'm multiplying by 10. So this is 10x squared, a negative 80x, and a positive 120. That's multiplying everything by 10 here. You change the signs because I have to subtract every single time. So subtract, add, subtract. Yes, it turns out to be a perfect remainder of 0. So what's my final answer?
X plus 10.
X plus 10. That was one of the roots. So at the back, how I created that problem, this is one of the roots. The other two roots was this problem factored out. So it was x minus 6, x minus 2. That was the other two. That's how I knew it was going to be x squared minus 8x plus 12. Now, if you knew how to factor the bottom, and this is what we'll talk about tomorrow more. If you factor out this bottom like you can factor apart, you can synthetic divide these out individually, one at a time. Because maybe you like synthetic division more than long division, because maybe you hate that. You'd synthetic divide these out one at a time. Do the 6 first, do the second, and you'll be left with the 10 last. That's what we'll talk about tomorrow. Questions? Perfect. Homework today. We only have 6 problems. It's on the first step we talked about today. Find possible roots, synthetic divide them out to find the others.
Are we graphing it all?
Nope, no graphs.
Perfect.
Boom, boom, no graphs. This is gonna be easy, short, simple problems. And the numbers I gave you are very, very straightforward. Okay, here it is. It's page 336. Numbers 14 through 24, and we're doing the evens. That's it. Just do the evens. Easy numbers. You're just finding possible roots. So list those out. You have to list them. Sometimes you divide them out and find the rest of them. You might have to do quadratic formula, but that's the only thing you're doing. You're not finding anything else. Okay? We will add, I know this is bad, we are going to add one more piece to this homework assignment tomorrow, which is the new stuff we're doing. Okay? We still have one more piece to throw in tomorrow, which is part of this section. It all makes sense why we do this.
Yeah, I tried brushing through my hair this morning, and it's not brushed through it, and it like went together even more. Like, it's not gonna do anything anymore. So I'm hoping that I'm gonna keep it like this for a little bit, like when I take it out, it'll be pushed. But I